In part 1, we wired everything up like this and ended up with a test station that looked like this. Let's apply power and see what happens. Uh-oh, we got an alarm code of 13. The product insert that comes with the drive has this little table of the most common error codes. Looks like we have a motor override condition. That's basically a simple e-stop that shuts the motor down without all the extra stuff you would find in a proper safety circuit. Now I have that switch labeled e-stop, even though it isn't a true e-stop, just because e-stop is easier to get on a small label than motor override. And sure enough, the motor override, or simple e-stop switch, is active. I'll undo that, and the alarm goes away. The buttons to control the drive are under this little cover. I know these buttons are hard to see in the video, so I'll leave this graphic I got from the product insert up for reference. The display basically has two modes. You can either monitor and manipulate stuff, or if I hit the mode key, you can configure the drive's parameters. You know you're in parameter mode because you'll always see this P here and this dot that separates the parameter group from the 3-digit parameter number. Now I've been messing with this system, so let's do a factory reset so you know exactly where I'm starting from. Use the left arrow to go to parameter group 2 and the up-down arrows to select parameter 8. Hit S to select that parameter and use the up-down arrow keys to change that parameter to a 10. Hit S to select that and the display says busy and then done. And you should always power cycle the drive after a factory reset to ensure everything gets updated. In the previous video, we hardwired the overtravel limits to not generate alarms. If I pull one of those wires to simulate opening the switch, sure enough, I get an alarm, which the product insert tells me is an overtravel limit alarm. And I'll put that back to get rid of the alarm. We could have skipped that bypass wiring and simply disabled the overtravel limits via parameters. The product insert has a list of all of the input pins and their default function. Looks like the overtravel limits are input 6, which defaults to the clockwise overtravel limit, and 7, which defaults to the counterclockwise overtravel limit. I'll hit the M key to get into parameter entry mode, and use the left arrow to go to group 2, and the up-down arrows to go to parameter 15, which controls input 6's function, and hit S to select that. We see its default is 022. The 0 tells us it operates as a normally closed switch, which makes sense because that will generate an alarm if the wire gets cut. I'll change that to normally open, and when I hit S to accept it, sure enough, I get an overtravel limit alarm. If I cut, or in this case, pull the wire, the alarm goes away. Put the wire back, the alarm returns. To disable that alarm input, I just set it to a 0 and hit S to accept it. Now I get no alarm regardless of wiring. Perfect. And I can just up arrow to parameter 16, which controls input 7, the other limit, and hit S to select that. I'll disable it by setting it to a 0 and hitting S. The normally open, normally closed digit doesn't matter if the input is disabled. Great! We now know how to configure and disable the digital inputs and navigate the display. Let's see if the servo motor's encoder's working. I'll hit the mode key to get out of parameter mode. If I hit the up or down arrow keys, I can scroll through all of the things I can do. We'll cover those in the display monitoring video. For now, we just want to monitor the encoder feedback, which is this FB for feedback. PUU stands for Pulse User Units, which reminds us that we're not viewing the raw pulses from the servo's encoder. Instead, we're monitoring the pulses modified by the electronic gear ratio in parameters 1.044 and 1.045. We'll learn how to use electronic gearing in the various operating mode videos. That message stays up for about a second. I stopped the video so you can see it longer. Then the display shows the data. If I reach over and rotate the motor shaft, sure enough, we see the pulse count change. This encoder has over 16 million pulses per revolution, but the default electronic gearing scales that to 100,000 pulses per revolution. So if I rotate this one revolution, yep, we see it rolls over to 100,000. If I press the left arrow key, you can see the upper word. So if I do another rotation, we see that increment. If I rotate it the other way 2 rotations back to 0 and then keep going, we get these weird dots everywhere. Those tell us this is a negative number. If I go 1 full rotation in that direction, then I roll over at a negative 100,000 pulses. Perfect. We can also monitor the digital inputs. We do that by setting parameter group 0, parameter 2, to a 39. So I'll hit the M key to get back to parameter mode, and hit the left arrow to get to group 0, and the up-down arrows to get to parameter 2. Select that, change it to a 39, and select that. It tells us we're going into display mode, and the display now shows us the digital inputs. If I pull the wire from digital input 6 to simulate an overtravel alarm, sure enough, we see the corresponding bit go active. This is a hexadecimal display, so that 2 in the second digit location tells us the 6th digital input is active. Now remember that we disabled that input, which is cool because that means you can test your digital inputs even if the input's function is disabled. If I toggle the alarm reset switch, yep, we see it working too. But if I toggle the e-stop, we don't see the status bit. Instead, we see an error condition. That's important. Error conditions always have a higher priority. But while we can't see the individual bit change, we know it worked because we got the error message. So how cool is that? You can monitor all of your digital inputs anytime you want right here on the display. That makes checking out your digital inputs super easy. Can we test the digital outputs? Sure. You can force any digital output active from the display. In parameter group 2, parameter 8, select that and change it to a 406. We could scroll to that, but it would take a while, so instead I'll just left arrow to each character and set it one at a time. Select that, we see the digital output force message for a second, and then it's ready to accept our commands. So we go to parameter group 4, parameter 6, and enter a hex value for our outputs. I wired digital output 1 to this beacon like this. So if I enter a 1 and select that, sure enough, the beacon turns on, telling us the output 6 is active. If I change that back to a 0 and select that, the light turns off. Perfect. Remember, this is a hex value, so a 2 turns on output 2, a 4 turns on output 3, an 8 turns on output 4, and an F turns on all 4. And a 0 turns its 4 outputs off. This forcing of the digital outputs will stay active until you set parameter group 2, parameter 8 to a 400, which I'll do here, or power cycle the drive. Now don't forget to do one of these, otherwise later you're going to wonder why none of your outputs are responding to normal operations. Okay, it's time to test the motor. Let's power down the drive just to make absolutely sure there's no power going to the motor, and finally connect the motor to the drive. I added a plastic pulley just to make it easier for you to see the shaft turning. You'll want to make sure there's nothing connected to the motor shaft until you're confident it's working the way you expect. Okay, I'll apply power to the drive, and we see our SureServo startup message. One of my favorite things about the SureServo system is you can jog the motor from the display. You don't have to connect any switches or other hardware, so it's super easy to test your motor. Right now, I can freely spin the motor because it's not being powered. I'll flip this switch to enable the drive's output, and now the drive won't let me rotate the shaft, and it's doing everything it can to maintain the current position. To jog the motor, just go to parameter group 4, parameter 5, and set the jog speed. Let's use the default of 20 RPM. The display tells us we're now in jog mode. To jog forward, I hit the up arrow, and to jog the other way, we just press the down arrow button. I'll press M to exit that, S to select the jog speed again, and this time let's go to 60 RPM, which is 1 revolution per second. Select that, we see we're in jog mode, so I'll play with the up and down arrows to jog the motor. Perfect. That's it, we're done. Let's recap. We wired everything up in part 1. Then in this video, we reset to factory default, learned about the alarm codes, and learned that the most common ones are in the product insert. We learned how to assign functions to digital inputs, how to disable inputs, and how to change them between normally open and normally closed. We verified the encoder feedback pulses, that negative numbers are displayed with extra dots, learned that the encoder has over 16 million pulses per revolution, but the default electronic gearing scales that to 100,000 pulses per revolution. We learned how to monitor the digital inputs, force the digital outputs, and jog the motor. Now, how did I know how to do all this stuff? Well, truth is, I didn't. I literally just walked you through the quick start section of the product insert. So if you have any questions, refer to that first, which again, you can always download for free from the automationdirect.com website. It's an awesome resource that you'll want to keep handy. So, what's next? Well, that depends on what you want to do. The Pulse Train video is for anyone that wants to control a CNC type of machine that expects pulses to control the motor. The position register video is for applications where the drive simply tells the motor to go to one position, then another position, like in a factory where you need to repeat the same exact motion over and over again. The torque mode video shows you how to set up the drive to handle situations where you need to maintain constant tension, like when you have a roll of paper or thin film or fabric that if pulled too slow messes up the process, but too fast rips the material. And finally, the speed mode is for those times when you need to accurately maintain the speed of something. This is ideal for controlling the spindle speed of a CNC machine or the speed of a conveyor, stuff like that. Be sure to check out all this drive has to offer: easy homing, quadrature encoder following, safe torque off, inertia estimating, auto tuning, PID, capture and compare, absolute positioning, electronic camming, and the free configuration software, just to name a few. And of course, we have videos showing you how to do many of those. Meanwhile, click here to learn more about the SureServo 2 system from Automation Direct and to find more of these videos. Click here to subscribe to our YouTube channel so you'll be notified when we publish more videos like this, and click here to learn about all of Automation Direct's free award-winning support options.